Okay, so let's take a look at number 7 from the Unit 12 review. So let's see. First thing, we've got a circle. Center point is P, 2, negative 6. And we know that A, 918, is on the circle for sure. So we need the equation of the circle. Well, that's going to be x minus h squared plus y minus k squared equals r squared. Well, they tell us the radius is 25, so this is going to be 25 squared. And the center point is 2, negative 6. So h and k are the 2 and the negative 6. So this is going to be x minus 2 squared plus y minus negative 6 squared, so y plus 6 squared, equals r squared, which is 25 squared. And if you prefer, you could switch out the 25 squared for 625. Okay, show that the point negative 518 is also on the circle. So let's try this. We can do it two ways. So method 1, find the distance from the center point P to B and compare it to the radius. Radius, which is 25. Okay. So if I draw that line right there, and pretend that you don't know that B is on the circle yet, well, I can make a little slope triangle. And let's see, it goes from 2 to negative 5 across, so that's 7 across. And from negative 6 to 18 is 24 up. So then if I do pi back there, I'll call this C for now because I don't actually know it's the radius yet. So I've got 7 squared plus 24 squared equals C squared. And if you work that out, let's see, that's 49 plus 24 squared is 576 equals C squared. You end up with 625 equals C squared, which the square root of that is 25. So then we can write a little sentence. Since the distance, or since, let's shorten this. Since B is 25 units from center point P, and the radius equals 25, B is on the circle. So that's one way to do it. Let me come up with let me show you a second way to do it as well. Okay, so method 2 would be to take the equation that we just came up with, and any point that's on the circle, any point, if I plug it in for x and y, if we get 25 squared, we know it's got to be on the circle. So the second method would be show negative 518 yields 25 squared when plugged in, or substituted really, in the equation of the circle. Okay, so we're going to take x minus 2 squared plus y plus 6 squared, and we're going to check if that equals 25 squared. So notice I'm using that question mark there because I don't actually know it equals 25 squared yet. And the x I can replace with the negative 5, and the y I can replace with 18. And when I work this out, I get negative 7 all squared plus 24 squared. And we're checking, is that equal to 625? And 7 squared is 49, or negative 7 squared is 49. 24 squared is 576. So we do indeed get 625 equals 625. So since negative 518, we'll say works in the equation of the circle, it must be on the circle. Or since B, point B, right? Okay, then it says prove using calculations that APB is about 32 degrees. So here is the angle that we're looking for, APB. Oh, and now we know this is 25. By the way, we also know this is 25. And if I end up making another slope triangle, let's say right here. By the way, this is just one way of doing it. This would be 7. It turns out 2 to 9. And then this would also be 24. So I actually have these two congruent triangles right next to each other. And we could do this a couple different ways. One thing I could do is I could solve for this angle, which is identical to that angle because they're the same triangle really, just flipped over. And then this angle right here would be 180 minus those 2 thetas because in all they make up that straight line there, that straight angle. So why don't we do it that way? So I've got this triangle right here where this is 7 and 24 and 25. We have all 3 sides, so I can use any trig function I want. Why don't we try sine? So sine theta would be 24 over 25. So theta would be sine inverse of that, which ends up being, let's see, what did that come out to? 73.739 something or other. 73.739,795. Well, I also have this one right here is also theta. And this is the angle that I want, and all 3 of these put together have to equal 180. So the angle that I want, APB, is going to be 180 minus both thetas, which ends up being 32.5204. So in D it says, suppose that APB is the base of a slice of cake with a height of 6. So APB again is this sector right here. Okay. Well, we know that the angle APB, this angle right here, is 32.5204 degrees. We need the lateral area of the cake. Oh, we also know the radius is 25. So we need the lateral area of the cake, which means the walls, not including the top and bottom. So let's break that up. The lateral area, you could think of this thing like a prism. The top and the bottom are identical, and it goes straight up and down. So if you wanted to, you could use the lateral area of a prism formula, which would be perimeter of the base times the height of the prism. Now, if you wanted, you could just say, well, let me just take this rectangle plus that rectangle plus the curved wall, right? That's okay if you wanted to think of it that way. But I'm going to use the shortcut formula because I think it's slightly faster. So here's the base right here, right? Now the perimeter of it's going to be 25 plus 25 plus whatever that arc is right there. Well, okay, so it's 25 plus 25 plus the arc length that I'm calling L times the height, which is 6. So I need L. So, well, L is the arc length of this sector. So L is going to be a fraction of a circumference that would look like that. So it's not the full circumference, it's 32.5204 out of 360. It's that fraction of the full circumference, 2 pi 25. And if you work that out, that ends up being 14.1897. So that's going to go here. So we got 25 plus 25 plus 14.1897 times 6. And if you add the parentheses together and then multiply it out, you end up with 385.138. Okay, so let's do number 8 as well. Let's take a look at 8. Okay, so find the area of the circle formed when a plane passes 3 meters from the center of the sphere with radius 10 meters. So the sphere has radius 10. Okay. So if I had a 2D version of this problem, then, and I cut it right there, I just get a segment. And this would be 3. And if I said what would be a good place to draw a radius, most people know, oh, this and this would be good places to draw radii. So same sort of thing applies in the 3D version. A good place to draw the sphere's radius would be right to there. That'd be 10. What is it? 10 meters. Okay, and this is 3 meters. So the question is, what's the area of this circle that's formed up here? Okay. Well, we need the radius of it. So let me draw on the radius. I'll call that x. And we've got this nice little right triangle to work with. So x squared plus 3 squared equals 10 squared. So x squared would be 100 minus 9, that's 91. So x is going to be root 91. Which means the area of the circle that has x as the radius is going to be pi x squared, which is going to be pi times root 91 squared, which is just 91 pi. 91 pi. And then we're working with meters here, so the area is going to be meters squared. All right, I hope that helps a little bit.